Intersection is all the elements that overlap in two or more specific sets, and the keynote for intersection is that the symbol used for intersection is this funny looking N shape. It's not quite an N, but it looks like that, and that's the symbol we use. So we've got three sets here, A, B and C, and we're going to look at the intersection of some of these sets. So if we start off with A intersect B, we have A and then the intersection symbol and then B, and this equals to the following set. So we need to look at all of the elements that overlap in A and B. In other words, all the elements that are common in both. So 1 is present in A, it's also present in B. So since 1 is an element of both of A and B, then it's also within the intersection. If we look at the next element, we have 2. So 2 is in A, it's also in B. So since 2 is an element of both, it's also in the intersection. If we look at 3, 3 is just in A, it's not in B, so it's not in the intersection. And then in B, we've got -1, but -1 is not in A, so it's not in the intersection. And 0, which is in B, but it's not in A, and so 0 is not in the intersection. And so therefore, A intersect B equals to this set here, 1 and 2. Both of these numbers are in both A and B. If we look at A intersect C, so we're looking at all the elements that are in both A and C, then if we look at the two sets, we see that the only number that's common in both is the number 3. So 3 is in A, it's also in C. And so A intersect C equals to 3 on its own. And we still use set notation. If we now look at B intersect C, so we've got B and then the intersection symbol C, we're looking at all of the numbers that are common in both B and C. So looking at this, we have 0, which is common in both, and no other number which is common. And so therefore B intersect C equals to the set that contains 0. We could also have the intersection of more than two sets. So we could have the intersection of A, B and C. So we would write that as A intersect B intersect C, and this would be all of the elements that are in A, B and C, so they need to be common in all three. So if we look through the numbers, 1 is common in A, it's common in B, but it's not common in C, and so that's not in the intersection of all three. If we look at 2, 2 is in A, it's in B, but it's not in C, so again it's not in the intersection of all three, and so on. So if we were to carry this on, we would find that there's no number that is common in A, B and C, and so therefore we use something called the empty set to indicate that there's no number or no element that is common in all of the sets here. So we would have curly brackets and there would be nothing inside, or we could alternatively say A intersect B intersect C equals to this symbol here, which is the symbol used for empty set. The next definition is union. So union is all the elements in two or more specific sets. And the keynote is that the symbol used to denote union is this funny looking U shape. It's not quite a U, but this is the symbol we use. So if we take the three sets that we had before, so A, B and C, then A union B would be written in the following way. So we're looking at all of the elements that are in A and B or in either of the two. So in this case, in A we've got 1, 2, 3, so we need to have all three of those numbers in our set, and in B we've got -1, 0, 1, 2, so we need to have all four of those numbers in our set. So if we write this in chronological order, we have -1, then we have 0, then A and B both have a 1, so we only include one of the numbers inside. We don't need to write two ones, we just write a single 1. Since remember, in sets we don't have repeats. Then we've got 2, so again 2 is in both A and B, but we only need to write 1, 2, and then 3 is in A, so we need to have a 3. So the union for A and B is equal to this. That's all the elements in A and B, whether they overlap or whether they don't. If we look at B union C, then we've got all the elements that are in B and C. And if we write this in chronological order, then we have -1, we've got 0, we've got 1, we've got 2, then we've got 3, 6, 9, and 12. So 3, 6, 9, and 12. And that's the union of B and C. And likewise, we could also have the union of all 3 sets. So we could have A, union B, union C. That's all of the elements that are in all 3 of these sets. And if we write those out, then in chronological order, we have -1, 0, 1, 2, 3, 6, 9, and 12. And that's the union of A, B, and C.